Dive. Today, we're plunging into a topic that's been sparking quite a bit of discussion in the AI world
Yeah, it's about these claims surrounding reinforcement learning, or RL.
and how it's supposedly improving the core reasoning abilities of large language models, LLMs.
And we've got some really sharp source material to guide us. It's based on a recent analysis, a Notion blog post, actually.
Right, the one titled Incorrect Baseline Evaluations Call into Question Recent LLM-RL Claims.
Exactly that one. Plus some supporting study notes and a timeline the authors shared. It gives a critical look.
So think of this deep dive as your shortcut to understanding a really important academic perspective on some, well, seemingly exciting AI advancements.
Mm-hmm.
Our mission today is basically to unpack the main argument from Nikhil Chandup, Shashwat Gol, and Ameya Prabhu.
Right. Understand why they're sort of pumping the brakes on some of those really splashy headlines we've seen.
Headlines about LLMs getting dramatically smarter almost overnight thanks to RL.
And why should you care? Well, it really challenges how we measure progress in AI.
Yeah, it forces us to think more critically about what these models are really learning versus maybe what they're just, showing us under specific conditions.
Okay, so let's jump right into the core argument.
The analysis points out this flurry of recent
Right,
papers.
papers suggesting these new RL methods dramatically improve LLM reasoning abilities,
And a big part of the buzz, it seems, comes from claims of seeing these big improvements even with random or no external rewards.
which, yeah, on the surface sounds pretty remarkable, doesn't it?
It does. Maybe a bit too remarkable.
Well, that's exactly the thread the authors pulled on here. They looked really closely at 7 prominent papers making these kinds of claims.
Papers that definitely got a lot of attention.
Oh, absolutely. And what they found, looking across these different studies, was this consistent, significant issue.
Which was?
The reported performance numbers for the models before any RL training started the baseline performance.
Okay.
They were often way lower, like considerably lower, than the actual performance you get when you evaluate those same models correctly.
So they're calling this underreported baseline numbers.
Exactly. That's the foundation of their whole critique.
So it's like saying the starting line in the race was marked way back, making everyone look like they ran faster than they did.
That's a perfect analogy. And they give some really specific, kind of eye-opening examples in the source material.
Like what?
We'll take the spurious rewards paper. They looked at the QN 2.57b model on the MATH 500 benchmark.
Okay.
That paper reported the pre-RL accuracy, the baseline, was just 41.6%.
41.6. Yeah, that doesn't sound great for a math benchmark.
Right. But then Chandak, Gol, and Prabhu went and evaluated that exact same model, QN 2.57b, on MATH 500 using, standard careful practices. The actual baseline accuracy they found, 64.6%.
Whoa, hold on. From 41.6% to 64.6%.
Right.
That's a 23 percentage point difference on the same model, same benchmark, just evaluated differently.
Correctly, they'd argue.
That seems like a massive gap.
It is a massive discrepancy. And crucially, it wasn't just a one-off thing with that paper or that model. They found similar patterns across multiple studies they reviewed.
Wow.
So this systematic underreporting, it fundamentally changes how you perceive the improvements claimed by the RL methods, doesn't it?
Absolutely. If your starting point is artificially low, any improvement looks huge.
Exactly. Even just fixing the evaluation might look like a big gain from the RL. And in fact, the analysis points out that in quite a few cases, the performance after the RL training
Yeah.
was actually worse than the correctly evaluated pre-RL baseline.
Get out. Worse.
Yeah, worse than the properly measured starting point.
So the RL didn't necessarily make the model better at reasoning than it was capable of being from the start.
That seems to be the strong suggestion.
It just made it look better compared to a flawed measurement of that starting point.
Precisely. Which suggests that a big chunk, maybe even all, of the gains being attributed to improved reasoning from these RL methods.
Might not be from the RL teaching new logical skills.
Right, it might just be that the RL training is maybe inadvertently fixing problems with the evaluation process itself.
Like teaching the model how to pass the test, not necessarily how to think better.
Kind of, yeah, learning the quirks of the benchmark rather than gaining fundamental reasoning power.
Okay, that definitely changes the narrative around those results. So if these big jumps weren't necessarily from new reasoning skills, what were these methodological issues? What caused those baselines to be so low?
Right, and this gets into the nitty-gritty of AI evaluation. It's really crucial academic work.
Often overlooked, maybe.
I think so. It raises really important questions about how robust our testing methods are for these incredibly complex models.
So what are the main flaws they identified?
Okay, one really big one is format following.
Format following?
Yeah, think about math benchmarks or other complex reasoning tasks. They often need the output in a very specific format so it can be automatically scored.
Like putting the final answer inside box?
That's the classic example. Exactly.
So the model could work through the whole problem, get the right answer, but if it just says the answer is 42 instead of box,
Gets marked wrong by the automated script.
even though the reasoning was perfect.
Precisely. And the sources really emphasize this. If the model fails only on the format, that's not an issue with the model's reasoning abilities.
It's a formatting issue or maybe a parsing issue in the evaluation code.
Right. And RL training, especially if the reward is just, did the automated script say correct, can basically teach the model to stick to that required format.
Which makes the performance jump look huge compared to a baseline where the model was maybe getting lots right, but failing on format.
Exactly. And they also warn about a seemingly obvious fix for the baseline.
Which is,
Just training the baseline model using rewards only for correct formatting.
why is that bad? Seems logical to make the baseline follow the format too.
Well, two potential problems they raise. One is under-optimization, maybe that format-only training just isn't good enough, and the baseline still doesn't follow the format perfectly, keeping its score artificially low.
Okay.
But the other, maybe more worrying, is catastrophic forgetting. If you train only on format, you might actually degrade the model's original reasoning skills.
Ah, so that format fixed baseline wouldn't even represent the original model's true potential anymore.
Exactly. So fixing the format issue in the evaluation itself, or using simple prompting tricks, is likely better than trying to train the baseline just on format rewards.
Got it. That makes sense. What else messed up the baseline scores?
Another really significant factor, temperature settings during evaluation.
Temperature, like how random the output is.
Yeah, the sources note several papers use very low temperatures, like 0 or zero point 0.1.
But wait, wouldn't you want low temperature for reasoning to get a single deterministic correct answer?
That's the common intuition, yeah. But research, even going back to 2019 with Holtzman et al., showed that very low temperatures, especially temperature 0 or greedy decoding,
Yeah.
can actually cause LLM outputs to degenerate, especially as they get longer.
Degenerate how?
They can become repetitive, nonsensical, or just kind of trail off before the model finishes its thought process.
And reasoning often needs long chains of thought, right?
Exactly. Models often think step by step using many tokens. If you force them into a low temperature straitjacket, they might not be able to complete that reasoning coherently or even state the final answer properly.
So the low score isn't because it can't reason, but because the generation setting hobbled it.
Precisely. You end up measuring an artifact of the generation strategy. Even official model releases, like for QN3, explicitly advise against using temperature 0.
Interesting. Okay, what else? They mentioned small benchmarks.
Right, the benchmarks like AIM or AMC only have like 30 or 40 problems.
That doesn't sound like a lot.
It's not, statistically speaking. The main concern is high variance in the obtained results.
Meaning the Swiss can jump around a lot just by chance?
Exactly. Like judging a student on just a handful of questions. A small change, maybe one lucky guess or one silly mistake, can swing the percentage score quite a bit.
So results on these small sets might just be noise.
They might just be noise, yeah. Especially if researchers don't report proper error bars or statistical significance. It makes it hard to be confident that a small improvement is real.
Makes sense. Need enough data points. And the last one was number of output tokens.
Yes, and this is super relevant for models that are designed to show their work, generate long step-by-step reasoning.
Like some of the newer models aim to do.
Right, they mentioned the DeepSeek R1 Distill model, for instance. These models might need thousands of tokens to fully explain their reasoning and arrive at the answer.
So if the evaluation cuts them off too early.
If there's a strict low limit, say 4096 tokens, and the model's full reasoning or just the final boxed answer comes after that limit.
It gets marked wrong again.
Yep, not a reasoning failure, it's a constraint failure imposed by the evaluation setup. It artificially pushes the score down.
So they suggest using much higher limits.
Yeah, like 32,000 tokens or more to give these models a fair chance to actually complete their output.
Okay, those all seem like really important practical evaluation details.
They really are. And it leads to what I think is the most academically insightful point they make.
Which is?
This distinction between truly improving reasoning abilities and merely eliciting previously underappreciated reasoning capabilities.
Okay, unpack that. Is RL teaching the model genuinely new ways to think, new logical steps, making it fundamentally smarter?
Or is it just helping the model finally show the reasoning abilities it kind of had all along, but couldn't demonstrate properly because of all those evaluation courts we just talked about?
Format issues, temperature problems getting cut off.
Exactly. And based on their analysis of those papers, the authors strongly suggest that many, if not most, of the reported gains seem to fall into that second category, elicitation.
Just bringing out what was already there.
Pretty much. They argue quite compellingly, I think, that a lot of this elicitation, getting the model to score better, could often be achieved without any weight updates or fine-tuning at all.
Wait, without any RL training? How?
Simply by fixing the evaluation setup, fixing prompting and generation hyperparameters, as they put it,
Meaning?
using the correct output formats, maybe better parsing on the evaluation side, using sensible temperatures like zero point 0.7 or whatever the model developers recommend, not 0.
Giving it enough output tokens.
Right. And even using simple stuff like few-shot prompting, just showing the model a couple of examples of the right format, or maybe a tiny bit of supervised fine-tuning SFT distillations focused only on format adherence for the baseline.
So doing that basic evaluation hygiene could get the baseline score up dramatically.
Often up to levels near, or sometimes even above, the performance reported after the complex RL training.
Wow, so maybe these celebrated RL wins are just fixing bad initial measurements.
That's the strong implication, yeah. And a key piece of evidence they point to is that most of the reported improvements on the base models,
The ones before any instruction tuning.
right, those improvements from RL do not surpass instruct model performance.
Meaning the models that were already fine-tuned for following instructions.
Exactly. Instruction-tuned models are generally already better at things like following formats and structuring responses. The fact that RL applied to a base model often doesn't beat a standard instruct-tuned version of that same model,
Suggests the RL might just be doing what instruction tuning or even just good prompting already does.
pretty much helping the model show its capabilities within the test's constraints. The real academic contribution here, they imply, isn't necessarily proving RL magically boosts reasoning, but highlighting how easily evaluation flaws can hide a model's true potential.
That's a really powerful critique. It shifts the focus from just the training algorithm to the absolute necessity of rigorous evaluation.
Totally.
So, if we want to get this right going forward, how do we accurately assess the impact of RL or any method on LLMs? What do the authors recommend for better academic practice?
Well, their main push is for much greater transparency and standardization in how research is reported.
Makes sense.
To avoid this kind of confusion and allow the community to actually verify results, they strongly recommend that paper releases should come with open weight checkpoints.
Meaning the actual trained model files.
Yeah, released publicly on places like Hugging Face, so anyone can download the exact model used in the paper and test it themselves.
Okay, that allows replication. What else?
Even more crucial, perhaps, is releasing sample-level outputs for all the reported evaluation numbers.
Wait, you mean for every single problem on every benchmark, they should publish the model's exact text response?
That's exactly what they mean. It's maybe the most impactful suggestion for transparency,
Why is that so important?
because it lets everyone see why the model passed or failed each specific test case. Was it a genuine reasoning error?
Or was it a format mistake?
Or did the output get cut off? Was the reasoning flawed, but the answer somehow right?
Ah, you can diagnose the type of error or success.
Precisely. This level of detail is essential for scrutinizing results and truly understanding where improvements are coming from or why performance isn't improving. They actually cite another paper, Sober Reasoning, as doing a good job with evaluation configurations, but adding the outputs would be even better.
That kind of transparency feels like it would build a lot more trust and accelerate real progress, right?
Absolutely. It lets others verify claims, understand failure modes, and build on solid ground.
What else?
They also recommend specifically reporting the fraction of samples where the model fails to follow the required format.
Just state that number clearly.
Yeah, it immediately flags how much formatting issues might be dragging down the baseline score.
Good point.
And of course, the big one is just ensuring researchers use appropriate prompting and generation settings right from the start.
Like, don't use temperature zero unless you have a very specific reason and document it.
Right. Use recommended temperatures, give enough token length for the output, maybe even use that quick SFT distillation trick just to handle formatting in the baseline before you start comparing any new RL method.
Basically, do your homework on the baseline measurement first.
Yeah, their core advice, the academically responsible thing, is to sanity check your baselines against official numbers for that model or against other well-established, rigorously evaluated results. Don't just take your first number as gospel if it looks suspiciously low.
This whole deep dive really drives home how fundamental and maybe underappreciated good evaluation methodology is.
It's critical.
It's not just about the exciting new training technique. This analysis shows it's just as much, maybe more, about whether we're measuring the starting point and the end result correctly, transparently, and robustly.
Yeah, the real academic insight from Xiaol.x, Goal, and Prabhu here is shining a bright light on the need for a higher standard of empirical rigor in this field, especially when claims about something as complex as reasoning are being made.
Absolutely. Their analysis provides this crucial, timely reminder for all of us researchers, developers, even users to look past the headlines.
Scrutinize the details.
Yeah, dig into how these experiments were actually done and reported by carefully uncovering these systematic evaluation issues.
Especially the underreported baselines, the format problems, the temperature settings.
Their work really calls into question the true size and sometimes even the basic existence of these claimed reasoning improvements from certain RL methods.
It does. It forces a reevaluation of those claims.
And it leaves us with a really important thought that chew on, straight from their conclusion. Do these post-RL results truly represent an improvement of reasoning or simple instruction following?
That's the million-dollar question, isn't it?
It really is, and it's a question that demands a more careful academic work, more transparency, and certainly a more critical eye on how we measure and talk about AI progress moving forward.